trigo proving question. This question is taken from the O-Level A-Math 2023 paper 1. We are tasked to actually prove this identity here. So what we'll do is, we'll obviously start from the left-hand side, being the side that is more complicated. Now, from the left-hand side, what you can do is, if you observe the denominator where you have cosecant minus 1, cosecant plus 1, notice A minus B, A plus B. This gives us your A square minus B square. Okay, so since your A is cosecant theta, it will just be cosecant square theta, okay, minus 1 square, which is just 1. Okay, now likewise over here, you observe something quite similar. Okay, secant theta minus 1, secant theta plus 1. Okay, so applying your A square minus B square, that will give us secant square theta minus 1 square, which is just 1. Now, every time you see squares of trigo function, consider using one of your identities given in your formula sheet. So cosecant square minus 1 is actually just cotangent square theta. Okay, whereas for secant square minus 1, that gives us actually just tangent square theta. Alright, remember that cotangent square plus 1 gives us cosecant square, and also remember that tangent square A plus 1 gives us secant square. So using these two identities, okay, we're able to show that cosecant square minus 1 is cotangent square theta and secant square minus 1 is tangent square theta. What we're going to do next is we will then try to combine them into one fraction. I'm going to then multiply this side here by tangent square, top and bottom. And for this one here, I'm going to multiply cotangent square top and bottom. Now, apart from making them have the same denominator, you do realize that when you actually multiply cotangent square with tangent square, this will actually give you 1, considering that cotangent square is 1 over tangent square. Alright, so this will actually give us 1. The whole denominator becomes 1, which means that we're just left with the numerator alone. Now, another thing I'm going to do is, since we have tangent square, and knowing that tangent can be converted to sine over cosine, so I can actually convert that tangent square theta to become sine square theta over cosine square theta. Now, I'm going to do the same to my cotangent square. Cotangent square is just cosine square over sine square. Like I said earlier, we don't have to worry anymore about the denominator because tangent square times cotangent square gives us a 1. And over here, you can actually simplify further because cosine square gets cancelled off. You end up getting sine square theta. And over here, sine square gets cancelled off. You end up getting cosine square theta. Okay, and you all know, right, that sine square plus cosine square, again from your list of identities, that this actually gives us 1, which is the same as the right-hand side. Therefore, we have proven this identity.